Okay, we are broadcasting live. Hello, everyone who's watching. Welcome to the Science on Google Plus Newtonmas Hangout. Feeling festive today. I'm Amy Robinson. I'm hosting this with Scott and Jason from Science on Google Plus. I'm coming to you guys live from MIT's Department of Brain and Cognitive Sciences. So this is a special holiday-themed hangout. We've called it Newtonmas because the wonderful Sir Isaac Newton was born on December 25th. So for all of you science enthusiasts, it gives you an entirely new reason to celebrate the season. And we're celebrating with a pretty interesting array of physicists and physically oriented scientists. Yes. So we'll do some introductions of people here. Why don't we just start with you, Carin Bondar?
Sure. Hey, everybody. I'm Carin Bondar. I'm not a physicist, but I am a science communicator. I'm actually a biologist, and I talk a lot in my various work about animal sex and the sort of processes that occur both behaviorally and physically during this process. So I have a rather interesting perspective on the topic, and we'll get to my thoughts later.
Yeah, we thought that since it's the internet and it's themed, physics, we
might as well. You need sex, really.
Yeah,
You've
right?
There's got to be sex. It's just the way it
goes. And we're also joined by Henry.
Hello. I guess I make MinutePhysics and Minute Earth. So I do some physics stuff and some other science communication stuff. YouTube videos, basically. That's what I do.
You have a few subscribers to your YouTube channel.
Yeah, I think so. I think some people watch the videos every once in a while.
What, 1 million? How many subscribers do you have?
MinutePhysics, I think, is like 2.1 million. I haven't checked recently. And Minute Earth is around 600,000, I think.
Oh my gosh. That's awesome. Oh my gosh. Okay, sweet.
So my name's Jason Davison, and I'm one of the curators on Science on Google Plus. I think we're just at, 200,000 people in our community?
Yep.
And I think we're about 400,000 in our plus ones on our page. So I'm also one of the curators. I'm a PhD student at the University of Waterloo working in earth science, and I do how climate change and water resources impact each other.
And I am Scott Lewis. I am everywhere. Let's see, I host the Virtual Star Party. I'm on the Science on Google Plus public database, and also work with the Hubble Space Telescope outreach team. So we do a lot of Hangouts on air and Google events with them. And yeah, we do a lot of science communication. I know a lot of us here are going to be at Science Online next year, so that'll be fun. We'll all get together and share even more stuff, physics and non-physics related.
Yeah, awesome. And I guess I should say what I do. So
what do you do, Amy?
Yeah, I work at a computational neuroscience lab at MIT, and I run a project called iWire. It's a game to map the brain, and we just got to 100,000 players on our one-year birthday last week. So we've got all these people helping us understand how the brain works by playing a game. Yeah, so it's pretty awesome. So the way that this Hangout is actually going to work is we've got a couple of questions that we've pre-planned to ask Henry and Carin, and we hear that Derek Mueller of Veritasium may pop in. He's in transit right now in Australia, so it's internet, depending on internet connectivity. We've got a couple questions to ask Henry and Carin, and then we're going to just open up the floor to questions from you live viewers. So the first question is a pretty obvious one, but so say you met Isaac Newton. Say he was just walking around and you got to talk to him. What would you say to him?
I have a good answer, I think. Hopefully it's a good answer. I would tell him, don't waste your time with the alchemy. It's true, it works, it is possible. Nuclear, you can fuse nuclei together, but you're not going to make any headway on it.
Yeah.
So that would be my advice. Or what is what I would say to him, if I could say something.
I would probably take a little more casual approach. Oh, look, Derek just popped in.
Hey, Derek.
Hey, Derek.
Welcome. That's Veritasium.
His logo.
Maybe. It's picture anyway. So I'll continue my...
It's just a headshot.
Tell Derek actually shows up. Hey, look, he's sexy and he knows it. There he is.
Derek.
Hey, Derek.
Your audio is muted, Derek, by the way.
Oh, shoot.
We were all commenting on your profile picture.
And it's pretty. Very
Sounds
pretty.
pretty. Well, Derek is pretty though. That's just a thing. So Derek, everybody's answering the question, what would we ask Newton if we were to meet him? So I was just about to say something like, I mean, to sort of approach somebody who is in such a state of intellect that's so much further above mine, further superior to mine, I would be kind of curious as to how his social game would be. So I might just ask something very casual. What's your favorite sandwich? I don't know. I don't know. He might have one.
He might.
Did they eat sandwiches
My
back
favorite's
in the day?
caprese. I like some mozzarella and tomato.
See? That's a good answer.
Yeah.
I would be like, yes, I would accept that answer. That's good. So Derek, what would you?
Were sandwiches
Derek,
Derek, why don't we have you introduce yourself really quickly?
That's oh sure. Hi, I'm Derek from the channel Veritasium, and I'm just currently driving from Sydney to Canberra, so I'm in the back seat of a car.
That's awesome.
That's good
Yay,
fun.
Internet! This is the future right
It's
here.
by the
It is.
Yeah, no kidding.
modern technology that I can talk to you guys.
I love how he's touting modern technology like you sound like a robot. It was awesome.
I'm tethered through my phone here, so
Awesome.
I don't know what to ask Newton.
I think I would
yeah,
ask
what would I
him,
ask Newton?
you're that old, what are you talking
Geez,
to
I
me
don't
for?"
know.
Yeah. Well, what would you ask Newton?
I think I'd be interested in kind of some of the mystical things that that he was into, like why he spent so much time working on, I don't know, working out Bible stories and things like that. I think the chair just moved in front of me. Yeah, so I think like he studied a lot of kind of mystical stuff in addition to things that were very scientific, and also the whole idea of like the 7 colors of the rainbow. Trying to figure out really why he was on about 7, why he really thought that had to be a thing. I feel like it's just historical reasons.
That's a really good point, actually, that Derek brings up, because, I mean, for those of us that are studying science and are scientists in the present day, our perspective on the religious part of science is so much different, I think, than it was in so many years past. And that's a huge influence on a lot of the theories and the way that they came up with the theories that they did.
It's also interesting to see the different writing styles that they had back then. How it was a lot more of like journaling almost. Like, have you read Origin of Species? I know Newton was much earlier than that, but they talk more like just some stories and some background information rather than like a literature review and other things like that.
Yeah, they were the first to do it.
Science
Exactly.
used to be so risky. Oh my
I mean,
God.
you
Yeah.
go based off of what you're surrounded with, and if he's really deep into Bible chronology and in the mysticism around that, 7 is a really heavy number, especially with the time and age that he was around. So I could see how that would really influence his research that he was going into and focusing on that, because that's what he has to play with.
At the same time, you look at the rainbow, and it's really hard to see what that there really should be only 6 colors in the rainbow.
Yeah. Indigo.
Only 6?
Okay.
Yeah. What is this indigo thing? Why is it different from violet? I can't
Doesn't
tell.
look like 7 colors.
Yeah.
I mean, it's a continuum of colors, but we have 3 cones, so there really are only 6.
Yes. Well, I think I would ask him, you're 371 years old. What are you doing talking to me right now? That maybe you played a little too much into your alchemy, and now you are a zombie, and I should be worried. But I think I would like to get his real opinion between him and Leibniz and figure out what's going on there, and if his development of calculus. I would really love to see what was going on in his brain as he's developing this, because some of us might have understandings of the need for calculus without knowing it, and I would love to see his process in actually going about developing it.
Well, I've got another relatively goofy question that has been inspired by Newton's first law of motion. So, as you all know, an object at rest stays at rest, and an object in motion stays in motion, unless it's acted upon by an outside force. So, we came up with an interesting scenario that I would like you guys to just discuss. So, say you're an astronaut and you're up in space, and you got an astronaut buddy on the other side of the Earth, and you want to throw a snowball and hit him. Now, ignoring the fact that your snowball would be ice and it would probably kill your friend, how would you do that? How would you do that?
So it's an interesting question because we're basically talking about orbital mechanics. And first of all, I assume because you're talking about Newton, we have to deal with Newtonian gravity and not general relativity. Not that it would make much of a difference, but it might affect how much the snowball is turning when it gets to your friend.
Does that change the way that it would impact your friend if it's turning more?
I mean, it would probably change some things. They might, angular momentum should be conserved, so collision, so they might start spinning differently than they would otherwise. But it's hard because you could say, oh, I should throw it either straight in the direction that I'm going or straight behind me, and if it was just going slightly faster than me, you could just tap it a little bit. It probably would end up, if it's going a mile an hour or a meter a second or something small away from me, it would stay in roughly close enough to the same orbit if I could get it perfectly in line with the orbit I was on, that it would eventually catch up to my friend who was going the same speed I am, because if it's going away from me, it means it's getting closer to him. But the problem with that is, and I don't know exactly how much this would affect it, but the problem with that is that if the snowball has enough velocity, then its orbit's going to change from being static to being, or from being circular, for example, to being more elliptical. And so if I'm over here and I give it a snowball enough velocity, this other side of its orbit is going to get bigger, and so it might end up farther away and miss my friend. So if that's the case, I don't think that is going to be a good option. So then, in which case, I don't know what the best way of throwing a snowball at your friend would be. And if you throw it backwards, then that part of the snowball's orbit would shrink in because it's going to go shorter, and so it might also miss your friend. So I don't know if it's. So you might just have to throw the snowball really, really slowly, so that it might take years to get to your friend. And then it would hit them when they're dead already.
Yeah, you didn't give it the timeline. So with the orbit degradation, it'll eventually hit him.
We'll just use geological timescale, and then everything works out.
Yeah, I was going to answer that, but Henry stole my exact answer.
But no, Henry, now you need to draw it for us. So please.
In a minute.
I'm expecting a MinutePhysics video on this. Thank you. So actually, the second question, inspired by Newton, skips over his second law and goes straight to his third one. And so Newton's third law is every action has an equal and opposite reaction, as you guys I'm sure already know. So this one again is space. And since we've got Carin Bondar here, and Henry and Derek, I wanted to just open up the floor for a discussion on the physics of sex in space. Go.
I have a lot of thoughts about this because I was asked a couple of years ago to give a speech at a symposium in Arizona, which was actually an astronomy symposium. And so I gave a talk entitled, "Why is there a biologist at an astronomy symposium?" And it was really all about the biology, and the physiology of things that can happen in space. And of course, sex is one of those things that nobody talks about. And I wonder if there is seriously a secret sex space race, because all the American astronauts say, no, we haven't done it. And all, everybody else, no, NASA won't talk about it. Nobody says anything. But it's a really interesting question, because if we don't know, and I mean specifically, I guess this pertains more to the moon, but if we don't know how the human body, or any body for that matter, can or mammalian, I suppose, can have sex, conceive, create an offspring, there's no way we're going to be able to colonize the moon and anywhere else. So it's not just a silly question. In fact, it's a really important one, and one that I think deserves a lot of thought, and probably is getting a lot of thought, but we're just not hearing about it.
So is a better question, is conception the harder thing, or is the actual birthing process, so the carrying and birthing?
The development would be the hardest part. If you're
totally agree.
How does microgravity affect the development of a baby or a fetus? And of course the moon is like a sixth the gravity of the Earth, so that it would develop differently than if it was in the ISS orbiting the Earth. And
could you think of bone formation in the womb? That would be really interesting, just because of the bone density really depends on gravity and pressure being put on it, and if there's a sixth of that happening, I'd wonder what would happen there.
But at the same time, a fetus is also kind of floating in liquid. So
True.
We were talking. I was thinking earlier, water-based things would see in some ways very little effect from being in space, because of, there's certain things would happen, but especially if you're really small, gravity doesn't really affect the day-to-day lives of bacteria very much. And so bacteria are fine, like they reproduce in space all the time. They're up there in the ISS, like people have them on their skin, that sort of thing. So the question is, when do you get big enough that something that having a lack or a smaller amount of gravity can cause problems for development?
I don't think it's been done successfully in any vertebrate organism. I know that some experiments with rodents have come out extremely poorly, and yes, I agree with everyone that the act of having sex is totally possible, no problem. There's actually a two-suit, it's called, and it was designed for that purpose, that two people could be together. It's like a double suit.
Russian or American?
It's American,
oh, okay.
And it was designed for
Has
that
it been
purpose.
done? Is this
Well,
a
this is the thing. Everybody says it hasn't been done, but I mean, why would there be a two-suit? Because of course you'd float away from each other. But you know, getting the sperm into the female reproductive tract, that could happen, because I mean, chances are that goes against gravity a lot of times on Earth anyway. But it's the development that would be a big problem. And of course, there wouldn't be any natural childbirth either, because of course we depend on gravity to get that baby out too. So interesting. I think we need to
carried a baby, but I would assume it'd be more pleasurable in space
Oh,
because you have the
zero
gravity
gravity.
effect.
You betcha.
So wouldn't that be like the dream of all mothers?
It's because
It'd be like,
when
let's
we
go to space and get pregnant.
or not even get pregnant, but like, yeah, when you're like 9, and I've done it 4 times, so I mean, when you're like 9 months pregnant and you feel like a house and you're just being in zero gravity would be awesome.
So you just feel like,
However, having a previous life being a paramedic and having delivered 3 babies, being on the other end of that does not sound awesome. That sounds
True.
that'd be a lot of fluids floating
You have
around.
fluids that are going to be flying around for a long time.
That's a good point.
That's really scary.
Is there fluids in the baby's like respiratory system when they come out?
Yeah, there. I
So
mean,
would
well,
those come
basically,
out, or they
Yeah.
just stay there.
You know, you use a bulb syringe to actually clear out the airway.
Okay, so
the
you
act
just see a
of
vacuum
going through
system.
the canal basically flattens out the lungs and gets all of the fluid out. It's meant to, and that's why natural childbirth, among many other reasons, is the best way to go.
Okay.
Children that are born by C-section don't
learning
have that
so
kind of
much today.
compression.
I'm learning so much.
See, I thought this was going to be about physics. This is awesome.
Well, it's all built on physics, right? So,
Yeah.
As
I
Henry
guess
pointed
I have
out earlier, everything is physics, basically.
right.
Mm-hmm.
Well, I have a question then. You know, getting back to Newton, is what was the first thing you learned about Newton, and was it completely wrong, and why? Because I know the first thing I learned about Newton was the whole apple falling on his head and made him think like a concussion made him think of gravity. But that's what do you know, what did you first learn about Newton, and was it completely wrong, and what is more interesting to you?
That's probably the first thing most people would have heard about Newton. I mean, I don't remember like consciously what the first time I heard about Newton was, but it was probably something to do with intro of a TV show, you know, Newton's Apple or something.
Right. I remember that show. That was awesome.
So yeah, so something along those lines, or either and then the next time you hear about it, it's Newton's laws in physics class. So.
But you often don't get taught about calculus until later on down the road. I mean, it's
And calculus, I feel like they skip a lot of the naming things after Newton as well.
that is true.
You know, physics names everything after people, and math they kind of just they name a lot of things after people, but they also name a lot of things after what they actually are.
Mm-hmm.
Right.
Things that they're similar to, rather than who discovered them. So that's different. So yeah, I don't know about Newton. Other than apple falling on his head, that's probably the most popular kind of thing that people would experience.
I think the whole apple falling on his head really takes away from his brilliance. Like, really, a concussion made him think of this. Like, that's kind of silly. You know, his mind had been brilliant just to be able to imagine forces and acceleration in an age that didn't have that sort of mindset of what's going on.
Mm-hmm. And as you go through the various stages of his life, too, from when he was a young man to sort of middle age to him in older ages, he had so many different ideas and thoughts and different developments that, you know, it's of course, to just sort of put that into an apple falling off a tree is, I guess, a bit demeaning. But then again, who doesn't know that story? So, I mean, his name is at least out there, which we can't say for a lot of major scientific figures in history.
Right.
We've got actually an interesting question coming in from the Q&A tool from Abby Bouchon. Hello. Hey, Abby.
Hey, Abby.
And she
Hi, Abby.
asks, out of all the awesome science things in all of science, what is each of your favorite science facts? Creativity is welcomed.
Cool.
Favorite science fact?
Drum roll.
That's a hard one. I will not say this is my favorite science fact, but this is a fact that I love a lot, is that stable orbits only exist in 3 dimensions. And so, like, the fact that the Earth can orbit the sun and not spiral in and crash into the sun or not fly off into interstellar space only works in 3 dimensions. If you try to set up the physical equations to work properly in 4 dimensions or 2 dimensions, it doesn't work at all. Like, there's no stability of orbits. And so the fact that we exist, like, it kind of requires us to be in 3 dimensions. Or technically, it works anywhere between 2 and 4, but not including 2 and 4. So, like, if you lived in 2.5 dimensions or 3.5 dimensions, it would also work. But that's a little bit harder to figure out what that means. So
I thought there's an analytical equation for 2-dimensional satellite like motion, isn't there?
yeah, but it's not stable.
Oh,
So
okay.
the orbit, if it gets bumped a little bit off the orbit, which, like, if you jumped or something,
Oh, I
might
get
get
you.
a little bit off. You know, it's like basically the difference between if you have a ball in a bowl and
Yeah.
the ball, you move the bowl and the ball stays in the bottom, versus if you have an upside down bowl and something balanced on top. As soon as you move it, everything will roll off.
Yeah,
Top
that
of
makes
the- top
complete
of the
sense.
hill.
So at the bottom of the curve. That makes complete sense.
Yeah.
Yeah.
So you only have this bottom of a curve kind of stability where if an orbit gets bumped, it'll go back to the orbit.
Yeah.
That only happens in 3 dimensions, and between 2 and 4, not including 2 or 4.
That is really cool.
And in 2 and all the other number of dimensions you could imagine for a universe, if gravity works the way it does, the way it normally does, then you don't have stable orbits. So things would either spiral in and crash or fly off forever, and so you don't get things like solar systems and galaxies and stuff. You wouldn't get any structure at all.
Hmm.
And I think,
Well, I would
the
take
structure of the
it.
universe is awesome. The way that the physics goes in and causes the structure to happen, just like the filamental structure of the universe is beautiful. And if you don't think so, then you need to look at it, because it's awesome. And you need to have those 3 dimensions, the way that they intertwine and play together.
All right, so I'll take it to a biological angle here, and I will answer that question by saying that evolution by natural selection is so powerful and so beautiful. And I might also add that Newton, I do not believe, had any children of his own. I don't think he actually was ever married or had children. And this is maybe a tragedy about somebody who has a mind that is as amazing as his was, that he didn't propagate that lineage. So it's kind of anti-biology. Yeah, so we can't forget that we're all biological creatures after all. That's my answer.
Good.
Awesome.
That's a good answer.
Should we move on to our next question?
Yeah, we've got, so the most popular question right now is for Henry, and it is, Henry, do you have a PhD? And if so, what was your dissertation?
Oh, this is a good question. I do not have a PhD. I have a master's of science. I decided to skip the PhD and get into filmmaking, which is what resulted in MinutePhysics. So I'm happy I didn't get a PhD because it means I'm doing this, doing what I'm doing now. But I did do a master's thesis on extensions of general relativity. So looking at, I don't remember what it's called or whether it's published anywhere, so you might not be able to find it. But it was basically looking at multimetric gravity. So the idea that there might be 2 different kinds of gravity in the universe and how that would affect things and the way that matter and other kinds of dark matter, that sort of thing, interact.
Huh.
And then Scott, did you get a PhD as well?
No, absolutely not. No, actually, I am still in school. I just decided to leave being a firefighter and paramedic and get into astronomy, and then I started producing and hosting shows and kind of going that route. So I'm actually still going in for my degrees. I'm planning on doing the whole master's route, just like Henry is, and while still focusing on doing video content. So I'm having a lot of fun, and it's, I don't know,
And
like,
Karen's a biologist, yeah?
I am, yeah. Mm-hmm.
Yeah, because we only have 4 minutes left, so I'm trying to plow through some of these questions. There's a lot of questions. Okay, there's one that is from Robert Jones, and he says, hold on, I have to mark this question is done. He says, can you explain the idea of Cherenkov radiation, particles that travel faster than light, and how does that influence the experiments going on at CERN?
So, who is that for? Anybody?
Probably you, Henry.
Okay, so
No,
I'm
that's for Carin.
you.
Carin, go ahead and take that, please.
The misconception about Cherenkov radiation is that the particles travel faster than light. They don't travel faster than like speed of light in a vacuum, which we call c, which is basically 3 times 10 to the 8th meters per second. Nothing travels faster than that, point blank, period. In terms of physical things, nothing physical influence can travel faster. What Cherenkov radiation is when something travels through a medium faster than light travels through that medium. So when light goes through water, for example, it only travels at about 2/3 the speed it does through empty space. And so an electron might be traveling at 90% of what the speed of light can travel through empty space through the water. And so the electron is traveling faster through the water than the light travels through the water. It's still traveling slower than light in a vacuum. So that's one misconception. And then basically what happens is the same way that if a boat is traveling on a lake faster than the speed of the waves on the lake, you get a wake. And a wake is effectively a shock. It's like a sonic boom is the same thing. So sonic boom, a wake from a boat, and Cherenkov radiation are all the same thing.
We've been
Hopefully
enlightened.
that answered the question.
There you go.
Do you want to do Bill Carter's question, Amy? Newton and his contemporaries.
Yeah, go ahead.
Irritable bunch, prone to spirited debates to the point of generating some of the most notorious scientific disputes of history. Name some of your favorites.
Favorite scientific disputes in history?
Yeah.
Aha.
Does anyone?
Anyone? Well, an interesting one is the question of whether or not the universe is expanding or contracting, or static. And I'm not sure how much of a dispute it was, but it's one of those things that very, very recently we have learned things about it. So I guess it was settled kind of in the 30s that the universe is expanding and not static, which it was thought to be static for ages. For millennia, people thought it was always the same way, and then they realized that the universe is actually expanding.
Well, I think that ties into what we were talking about earlier with Newton's, view, and goes. Yeah, they thought it was a static universe because that's what's been taught to them from a religious standpoint. It's been perfect. It's not moving, and then we're finding evidence.
It's also what they observed, though. They didn't have the technological ability to observe anything other than static universe.
Right.
Yeah, and I think, Scott, you bring up a good point there, too, which is a lot of the great debates in history that have had to do with science versus non-science, and not necessarily this science or that science, have sort of had those religious undertones to them, for sure.
I think that's one thing the public also often doesn't recognize is that there's still debate going on in our research that we do, where we still debate back and forth on what's the actual science and what we make up. And we conflict and write papers on that.
Well, and that's a lovely point about science, is you're always getting more evidence, and so you can always refine it to make it better for the future. That's the whole point of it.
More tools, more ways to see the world,
Yes.
more ways to interact with the world. Oh, it's so amazing. I mean, people used to have to write letters. But now we're doing a live Google Hangout, interacting with awesome rock star scientists streaming on the web. I mean, this is amazing. And it's 6:30, so we're going to sign off. But I want to thank you, Carin and Henry, for joining us.
Thanks for having me.
Yeah, thank you.
Good to see you, Henry. Good to see you guys, all of you.
You guys are awesome.
Yeah.
Thanks, Derek, for popping in. I hope you have a good rest of your car trip. And Jason and Scott, of course, from Science and Google Plus. Thanks for joining the conversation, and all of you guys who watched live and asked interesting and intelligent questions. We will continue to do more Hangouts on air with Science on Google Plus, and I'm sure we'll see you in the future.
Yeah,
so,
for sure.
wishing you a happy Newtonmas.
And real quick, we'll be having, speaking of Newton, we'll be doing another Hangout on air in about 3 hours' time, 2 hours' time, about Newtonian telescopes. So, beginner's guide to buying a telescope. On our channel, we get so many questions about what telescope should I buy. Well, we're going to be doing a Hangout on air to discuss those questions, pitfalls, and some tips and tricks on getting into the wonderful world of observing the cosmos. So we'll see you there.
Sweet.
Great.
All right, thanks for having us.
Goodbye,
Thank you.
guys. I'm ending the broadcast.